So now let's look at something called gram to gram stoichiometry. So we've looked at mole to mole, which was nice and easy. We used the mole ratios that we get from the coefficients in the balanced chemical reaction. But now we're going to look at something a little bit more practical, which is gram to gram stoichiometry. And we're going to start with a question. Which do we measure in lab? Do we measure grams or do we measure moles? Well, let's think. When we mass something out, what are the units that we're using? Are we getting grams of a substance or are we getting moles of a substance? Well, we get grams of a substance. When you mass out when you measure or mass out different compounds in lab, you're recording those in grams. We don't measure in moles, okay? So that's something we kind of have to think about. That practically we don't measure in moles, we measure in grams. The second question I want to look at is 12 grams of hydrogen the same as 12 grams of carbon? No, it's both 12 grams, but it's different numbers of particles. 12 grams of hydrogen would mean you have 12 hydrogen atoms. Each hydrogen has a mass of 1. So each hydrogen equals 1 gram. Whereas carbon, one carbon has a mass of 12 grams. So if we have 12 grams of hydrogen, we really have 12 hydrogen particles. And if we have 12 grams of carbon, we have 1 carbon particle. So this is the basis for gram to gram stoichiometry. Is first, we don't measure moles in lab. And second, you can't compare grams of one compound to grams of a different compound. You have to compare through moles, which means that we're going to have to convert from grams to moles and then look at the relationships. So let's walk through an example because it's the easiest way to explain how this is going to work. So our first example says, if you decompose 10 grams of sodium bicarbonate, NaHCO3, how many grams of water, H2O, will be produced? So here's our balanced chemical reaction. So we have 2 NaHCO3 decomposing into Na2CO3, CO2, and H2O. So we have our balanced chemical reaction. And so we're going to start with what we know. What we know is we have 10 grams of our sodium bicarbonate, so NaHCO3. Now, can I compare grams of NaHCO3 to grams of H2O? No, we already said before that we can't compare grams of one compound to grams of another. So we need to convert to moles. So just to kind of map this out, we're going to go grams of NaHCO3 to moles of water, and then we're going to go to grams of water. So this problem is going to involve several steps, and we're going to do each step individually. So our first step is to go from grams of sodium bicarbonate to moles. And to do that, we need the molar mass. So I know that for every 1 mole of NaHCO3, we're going to get whatever the mass is of sodium plus hydrogen plus carbon plus 3 oxygen. So we're going to get that from our periodic table. So we're going to add up sodium plus a hydrogen plus a carbon plus 3 oxygens. And I get a molar mass of 84.01 grams. So for every 1 mole of NaHCO3, I have 84.01 grams. So now if I do 10 times 1 divided by 84, I get 0.119, I'm going to slide that over, 0.119 moles of NaHCO3. Now that I have that in moles, now I can compare moles of sodium bicarbonate to moles of water. And to do that, I'm going to look at my coefficients in my balanced chemical reaction. So this tells me for every 2 sodium bicarbonates, so for every 2 moles NaHCO3, I get 1 mole of H2O. So I get half as much water as I have sodium bicarbonate to start with. So if I do 0.119 divided by 2, I get 0.0595 moles of water. Okay, so that was I'm here. So that was this step. So I've gone from grams to moles. That was this step here. And I've gone from moles of sodium bicarbonate to moles of water. That was this step here. And now my last piece is to go from moles of water to grams of water, because my question asks for grams. So I'm going to take this number of moles, and I'm going to go back to grams, which means I'm going to multiply by the molar mass. So for every 1 mole of water, I'm going to add up 2 hydrogens plus an oxygen, and I get 18.01 grams. So for every 1 mole of water, I get 18 grams. I have 0.0595 moles of water. So if I do 0.0595 times 18.01, I get 1.07 grams of water as my answer. So there are several steps to this problem, but each individual step is fairly simple. It's just a matter of keeping the steps in the right order and making sure that you do everything. So we had to go from grams to moles, then moles of one substance to moles of another, and then back from moles to grams of our new compound. So let's do one more example. In this example, we say that we react 20 grams of oxygen with excess hydrogen. That just means we're not really going to care about the hydrogen that much. There's plenty there to do the reaction. We don't worry about that number. How many grams of water do you produce? So we're really looking, if we have 20 grams of oxygen, how much water are we going to make, given that we have plenty of hydrogen there to do this reaction? So we're going to do a similar process. We're going to go from grams of oxygen to moles of oxygen to moles of water, and then back to grams of water. So there are 3 steps to this. Our first step is to go from grams of oxygen to moles of oxygen. So I have 20 grams of O2, and so I'm going to divide by my molar mass. So 1 mole of O2 is equal to, so it's O2, so 15.999 times 2, which gets me 31.998 grams. So I have 20 divided by 31.998 gets me 0.625 moles of O2. Okay, so I've done this first step. Now I'm at moles of O2. Now I have to figure out how many moles of H2O I'm going to have. So if I have 0.625 moles of O2, I'm going to go to my coefficients from my balanced chemical reaction. I know I can see here for every 1 O2, I'm going to produce 2 moles of H2O. So for every 1 mole of O2, I'm going to produce 2 moles of H2O. So if I'm starting with 0.625 moles, and I'm going to end with twice as much, I'm going to end with 1.25 moles of water. So now I've done this step here in the middle. I've gone from moles of oxygen to moles of water. And now I just need to finish it out and go from moles of water to grams, because that's what my question asked me for. So if I have 1.25 moles of water, I'm going to multiply by the molar mass. So for every 1 mole of water, molar mass of water is 2 times 1.0079 plus 15.999. I get 18.01 grams. So that's mass of 2 hydrogens and an oxygen. So if I do 1.25 times 18.01, I get 22.5 grams of water as my answer. So if I react 20 grams of water with lots of excess hydrogen, I'm going to end with 22.5 grams of water at the end. So 20 grams of oxygen with lots of excess hydrogen gets me 22.5 grams of water at the end. And that's how we can go from grams of one compound to grams of another compound.